So we move on to the next speaker of the session, and pretty interesting one from Amazon. Madhusudan Shekar, who is a principal evangelist at Amazon Internet Services, and he's going to talk about leveraging geospatial signals for business insights. Come on in, Madhusudan. Thanks a lot.
Good afternoon. I'm the one stopping you from getting to lunch. All right. I do have slides. This is, I don't know if it's a technical or non-technical talk, but I'm going to try to keep it as non-technical as possible. And it has very little to do with Amazon. Let me put it that way. Right. You will see some slides that will have Amazon logos and Amazon use cases in there, but it's got very little to do with that. Before me, there were speakers who have done a phenomenal job of setting up all kinds of different contexts to where I'm coming up, right? So we talked about healthcare, we talked about the computing on the edge. Sandeep talked phenomenally about the way they're bringing the data platform together, and Dr. Srinivas talked about how the context of AI and the mechanics of how we think about it is all changing. I'm going to talk about three fields: latitude, longitude, and altitude. That's all, right? That's geospatial, right? Let's see. Does it work? Nope. Either one. Let's try switching it off, switching it on. If somebody's there, just change it to the next slide. There are like 7 slides in there. Not a big deal. Just move to the next slide. Anyway, so I'll talk about what is geospatial, right? It is about where. It answers only one question. It answers the question where. That is geospatial, right? We'll look at what you can use it, how you can use it, what are the advantages of it, etc., very interestingly. And when we talk about where, right? And let's step back and think about what we're trying to do today is when you're building IoT systems, or for that matter, any business system today, we make a fundamental assumption that our data and data quality is good for us to be able to have these fantastic algorithms help us make decisions. Correct? That's largely how we start. Now, if you can quickly go to the next slide. You see 2 addresses on there. Would you have remotely imagined they're only 2 kilometers apart? Right? The first one is an address that says I'm in Sarjapura Attibele Road, Bangalore, Karnataka, 562125. The second one is in Tamil Nadu in Krishnagiri in 635103. They're actually exactly as the crow flies 2 kilometers apart from each other. If you're building a sales system, if you're building a marketing system, building cohorts, buying patterns, if you're trying to do risk analysis, if you're trying to do predictions on events, addresses are no good, right? They actually occupy a lot more data. They actually occupy about 250 bytes in your storage, but you really need to store only 7 bytes, right? Latitude, longitude, to a certain extent, in some cases altitude, because once you have that, you have the ability to visualize the world very differently. And this is what, I mean, through my experience and prior to my role in Amazon today, I was the CTO of Tata Motors, and where I built Tata Fleetman, which is a fleet telematics product, right? And one of the classic things we learned there was that if you start putting latitude, longitude on some extremely simple data, you start getting some very interesting effects coming out of it. You start saying, okay, you know what? Why is this person stopping here? Where is my real customer? Think about it, right? If you want to set up a service network in the country to service your products, let's say, for example, you sell refrigerators or trucks or cars or I don't know, calling bells, doesn't matter, right? If you're selling that, the best data you have as a consumer durables or a manufacturing company is at the point where your offtake happened, right? Which is your distributor buying it from you or your dealership buying from you. The next level of data, if you're an automotive company or some of these things, is the next level of data you have is the address of that customer at that point of first registration. Once your car gets resold, you have no idea what happened, right? Generally, it's gone off the radar. Classically, right? That's your first challenge. That means you really don't know where your cars are going to come up for service, or if you're in a consumer durable business, you really do not know where your customer is using, what they are using it for. Right? You're doing market surveys, which is actually a proxy for some broad-based statistical approximation, to tell you, you know what, that's sort of what I think it is, and then you start making a lot of decisions based on gut. And that data fed to AI is actually even more interesting. It gives you gut results. Right? I mean, all these professionals in AI who spoke about today will clearly tell you that sample set is terrible. And your data scientist will tell you, God help all of us. Astrology might be better. Right? That's sort of the situation we are in, right? So, what these three data fields tell you is a substantial level of accuracy. Of course, you have to record it accurately. You have to retrieve it accurately and store it, and there's a bunch of challenge around hardware, software, systems, etc. around that. But assuming you have a good way of capturing this data and you bring it in, then what ends up happening is you have this context where you suddenly start seeing interesting patterns. And here is an example of where I pulled up data from postal code in the United States, zip code in the United States, from Zillow, which is a real estate player, which is very, very similar to many of the real estate players that you have in India. The only reason I use Zillow is largely because they're an AWS customer, so don't worry about it. Right? So that's easy for me to put on the slide. Otherwise, I'll have to write all kinds of disclaimers on the slide. So that's Zillow. Basically, the minute you start seeing that, you start seeing a very interesting pattern, right? You start seeing that single postal code, there's a nice geographic boundary, and you start seeing clusters of sale, buying patterns, etc., etc. And it says what was foreclosed. All the blue dots are foreclosed, and all the red dots are house for sale. Right? Now your market is much more interesting to see. I mean, if you use any of your rental apps like Magic Bricks or any of these things, you're seeing that, right? It's much more visually easy to see. Saying I want a house in Koramangala is not helpful, right? Because your traffic patterns in Koramangala can shift from 5 minutes of trip to your work to 5 hours of trip to your work, depending on where you are in Koramangala, right? Based on, I live in Velandur. Getting out of my house is a 1 hour journey to this place, right? I live right here. Right? And I don't know if you live in, if you work out of the Flipkart office nearby, you know the travails of leaving in the evening, right? It's simply a matter of few meters, right? And Bangalore can create massive, and sometimes walking is faster. We have all seen that on WhatsApp, right? So geospatial intelligence gives us that amazing ability to start allowing people to make decisions much more visually. I mean, if you step back and think about it, what did our ride sharing services really do? Uber, Ola services, right? Do you think the previous players to that did not have that capability? They had cab services, you had websites, they had a mobile app. What happened was the inversion of the flow. You basically went to the mobile app and said, I want to go from my house to my work. That's all you said, right? I want to go from my house and then I want to book a car, which was actually an isomorphic replication of the experience of how you booked a car on the phone. What ride sharing service did was flip it. And they said, I know your location. I'm going to show you what's available nearby. That was simple geospatial intelligence. They didn't even have to ask you where you were. They took 3 fields, figured out where you were, and flipped the equation. So you didn't have to say, I want the car here. It was just right there. You immediately had visibility to what was nearby. Because they knew where you were, they knew where their cars were, and they could just link that up. All the previous players had the same data. Right? It's not like they did not have this data. If you go back to their old websites, you can do that on Wayback Machine and stuff like that. You can go back and take a look at those pages. It's actually very interesting. Right? It was there. So real estate, Zillow has an underlying engine. It's called Zestimate, and what it does is it starts using AI because of this data that they have by geographic lat long data. They actually estimate what price your house will close. They not only just tell you this is your price, but given the specs of your house, what price it will close. Right? Simple example, and that gives you an idea of like, if this house comes for sale, I know what I'm going to do, or if you're a seller, you know what my house will sell for. Right? It's not just simple rate per square feet, right? This is the company I worked for before this, and that's what we did. We collected data from all kinds of trucks, preventive maintenance. Dr. Srinivas spoke about it. The idea was to figure out when will trucks fail, but very interesting. Trucks driving in high altitude regions, in roads that were not structurally better. What is the tire lifetime if the roads are not good? Let's take Bangalore, right? What is the life of a tire in Bangalore versus life of a tire on? So for example, once you start getting your sensor data of what routes it has taken, because when a customer comes and complains, you know what, the tire didn't come for 60,000 kilometers, you can go back and take a look and say, you know what, you've been driving in outer ring road. Tough luck, right? Because if you've been driving on one of the national highways, you can do a lot more than 60,000, but you cannot do that here. Because wear and tear of a product is simply a function of what you are using, where you are using, and the conditions of the terrain, right? Same goes for oil, same goes for pollution. The lifetime consistency, the fuel efficiency that we are talking about, right? So one of the things that we did was we did driver performance management, and driver performance management in Tata Motors is very interesting, right? We detect fast lane changes, hard acceleration, and hard braking. 3 parameters on the geospatial coordinates. Once you develop that model, something very interesting starts showing up. You start seeing driver behavior. You start figuring out whether this was driver cost or environmentally cost. Two different sets of values, right? This is cost because of the fact you're driving in this terrain, it's going to be bad. You're going to go up and down the gear range, right? If you're driving in a different scenario, you're going to see a very different situation. That means this is actually cost by the driver. I mean, if you're on a 6-lane highway and you're constantly going up and down your gear range, there is a better way to deal with this, and the driver needs to be trained better, right? Because if the driver is trained better and the driving practices are better, you have a higher order fuel efficiency, and all that you have to do is save 5% on fuel efficiency, right? If for a truck driver, that's between profit and loss, what it makes, right? Remember, 26% of a truck operating cost is fuel, right? Runs a lot. Monsanto here, another use case, again AWS, so but agriculture company, right? So they do geospatial data access. What they do is they basically pick up the weather data, harvest data, their mapping data, planting data, phenotype of the actual seeds that they've been used, put that all together, and they do this brilliant phenotyping at each level. They identify the interactions that is causing between acres, between the different plants and the soil conditions, and start giving specific prescriptive recommendations to farmers on how to treat the plants at a very, very micro level, right? So they can understand at an acreage level what is going on with the plants, and they actually ensure that there's a high level of sustainability and output throughput that they're able to get out of agriculture. Remember, agriculture is still flat, it's not gone vertical yet. People are still trying it. There's a lot of space there, but that's largely what they're trying to do there. So there is a whole ranking system that they go through, they identify, they visualize it, and they create the environment classification engines, and they do it at scale. They can actually look at it at a national level. They can see how certain crops, what is the yield levels it's coming in. Now they can make better recommendations, better predictions. Again, 3 fields along with your data extra. Because I can say it's happening in the state of Kansas, doesn't help. I can say it's happening in the city of Boston, doesn't help. Where in Boston? How is it happening? What's the nearby impact? How it's happening, right? That's visualization. Because now your AI engines are smarter because you have real data. That's your spatial data about. Transport for London, another interesting use case. They did a brilliant job. I mean, I love this use case largely because of a very simple fact. What they did is they had this GPS data coming out of all their infrastructure, subways, buses, tunnels, taxis, etc. Excellent data. They said, we're going to aggregate all of that and we're going to give you APIs. You guys do what you want. You know how many apps are there in London that can actually help you move? Take a guess. Hundreds. Right? There are hundreds of apps in London that can help you, and each one of them is for a different purpose. You could be apps for going from place A to place B, booking tickets, following an experience, right? You could have an app that basically says, I want to book an experience. Now I also want to travel there. Tell me what's the best way to get there, right? And all of that is possible largely because of aggregation of this geospatial data, bringing it together and building solutions and saying, I'm going to share this with you. This is largely government thinking. Right? Business thinking is how do I monetize it? Government thinking is how do I share it for the greater good? Right? Very different thinking, very different approach to how they brought about doing that. right? And they have an entire developer network. Can you imagine that? Right? And that's largely what we're doing with India Stack here, right? Getting a developer network going on top of that. Another interesting set of use cases is crisis management and situational awareness. So whether it's the fires in California, floods in India, and many of us have faced these geographical challenges, complaints. The thing is, the minute you have low level data at a geospatial level that says, I know this problem is occurring. I mean, for example, when we had, I think there was a couple of weeks ago, we had floods in front of RMZ EcoSpace in Bangalore. There was no other flood in Bangalore. Just in front of RMZ EcoSpace, there was enough water that you couldn't traverse anywhere. Right? And it showed up on Facebook and WhatsApp, a little more than geospatial. There was photographs, and everybody will start inquiring you, what's going on in Bangalore? Nothing. Right? What's going on in Bangalore, RMZ EcoSpace is filled up, and it was good, because if I lived there, nobody was coming to work for 2 days. Right? And I could actually move back and forth quite easily. I have a nice big SUV that just runs over the water. Right? But again, geospatial intelligence. That means, remember, the response teams, the best part is what the Bangalore police did. The response team got in, they actually had to pump the water out. But if you don't have that situational awareness application with just these 3 fields of data, your ability to respond, act appropriately and correctly becomes a challenge. You can see a number of use cases. This is a really nice thing that I like. In GitHub, you have this source code, and this GitHub is great, right? You don't have to do anything anymore. If you're a good software developer, you know how to leverage GitHub. And if you're not doing, you're not a good software developer. Let me put it both ways. Right? Don't try to invent anything. Go to GitHub, it's generally there. Right? Reuse, reuse, reuse. That's the best form of object-oriented programming you can imagine. Right? First responder is amazing. It gives you a bunch of mobile apps, a bunch of capability. It's developed with the Department of Homeland Security. Right? And it's being used in a lot of places. Comes with all the necessary data sets. It actually stores the data, helps you give you visualization, helps build visualization. Very nice piece of code. You just need to start recording the data and sending it in. Whether it's, I mean, and remember, your cell phone pictures, most of us, we do this, a good thing to do is to generally switch off the geospatial data that your picture captures. If you're taking a photograph in your cell phone today, most phones record your GPS coordinates in the photograph. Right? And when you generally share it on Facebook or one of the social platforms, you disable that capability to say that that IPTF information should not go out. Right? Which is also a good thing. You don't want people to know exactly where it was, and generally it's possible to detect it. But the more interesting thing is, if it is saved that way, you can actually do some very cool stuff with that data. Right? I mean, if you got all your vacation photographs with all your GPS tags on it, you can actually plot them on Google Maps very easily. Right? It's a nice way to remember, you know what, where is this photograph taken? Ah, it was taken there. Right? Very simple use case from a personal level all the way to the highest levels. And people share photographs that says, I have a national calamity here, I have an accident here, send it to the GPS coordinate. Right? People can respond very, very actively, very quickly. Right? I'd like to rest with that. This is a nice URL. We have all of these models free. Free in the sense it's available very quickly. Climate models, aerial imagery, elevation models, satellite imagery, high resolution radar on AWS at amazon.com/earth. There's credits available for people to build stuff on top of it. Right? And if you're a researcher, scientist on geospatial sciences, just go to the URL, Landsat pictures with extreme high resolution, sub 30 meters, available for you to use. Digital globe, all kinds of POI data. I think somewhere around 6 million POI units are available for you to use. Ready, just it's an S3 bucket, take over, build your analytical application solutions, try and see what you can do with it. Thank you.
So Madhu, thank you so much. I mean, a lot of interesting insights, and it's education for me too on geospatial stuff that you're talking about. So thank you very much. Can we kind of have the memento here, please? Yeah. Let me kind of give that to you.
Great. Thank you.
Thank you so much. So